Good afternoon, everybody. Hi, my name is Adrian Hill. I'm the Automotive Product Manager at Morris Lubricants, and today I'm going to give a glimpse into the near future. That's me glimpsing into the near future with a bad hair day, so I'm always better after a bit of a wash and a quiet walk around the block on my own. So yeah, what's happening in the near future? Well, we work very closely as a company with our lubricant technology providers, looking at market trends, talking to customers, getting as much feedback as we can. So hopefully today what I want to do is just give you an idea of how things are evolving in terms of engine oil technology and what you can expect to see more and more of as we move forward over the next couple of years. Okay, so we've seen some evolutions. We've seen some things change. Obviously the passenger car has evolved dramatically and radically over the last 100 years or so, including engine technology, so that's changed dramatically. We are seeing as a company, of course, hybrids coming along, which are very important to us because there's still an internal combustion engine there we can lubricate. There was going to be a slide 4 with a picture of a battery on it, but unfortunately that's not very interesting from an oil company perspective. So slide 4 was taken out of the slide deck. Okay, so things are changing. Things are improving all the time. And what we've seen, of course, since the early 90s is the reduction in emissions from exhaust gas. So these are the important ones. These are the ones that we've targeted and highlighted for, as I say, since the early 1990s. So we have our NOx gases, we have particulate matter, which is the solid debris which comes out of the exhaust pipe. We have hydrocarbons, which is basically unburnt fuel, and then we have carbon monoxide. So these are all fairly nasty in their own kind of way, if you like. So we've seen an evolution in basically after-treatment devices and engine technology to reduce these, pushed of course all the time by emissions legislation. So if we have a look at this, I'm sorry if the pictures are small at the back, but don't worry, I shall describe to lots of detail. So in order to achieve reduced emissions of all these different nasties, there's been a lot of after-treatment devices developed, a lot of hardware being developed in order to reduce them stage by stage. So if you look at things like NOx gases, for example, we've seen the introduction of EGR, exhaust gas recirculation. That's around the late 1990s, that first emerged with heavy duty. We've seen SCR, which is the AdBlue system. Of course, that's very much prevalent now in the passenger car light van market. 2 litre diesel and above now, you're getting fitted with AdBlue. Although interestingly enough, it's been around for probably a good 5 or 6 years in certain models, so it's already been out there in the marketplace. And then diesel oxidation catalysts. Again, primarily on the big stuff, but we're seeing DOCs now as something which is getting included into passenger car engine hardware technology, especially where certain DPF regeneration techniques require one of these things. Okay, then we have particulate matter. So the old diesel particulate filter, which is a special favourite of mine, which caused lots of problems when it was first introduced. Diesel particulate filter blocking was a big issue until engine oil technology improved to a level where we could obviously help prolong the life of the diesel particulate filter. And again, diesel oxidation catalysts. Diesel oxidation catalyst comes up quite a lot because it's a kind of a clean-up device. So it has a little go at all these nasties before the other devices get to take their turn. So diesel oxidation catalysts are also involved with taking hydrocarbons, turning it to basically water and carbon dioxide. Then we have hydrocarbons. So essentially this is unburnt fuel. So if the fuel system's not operating correctly, you will get unburnt fuel going down the exhaust pipes. So of course we've seen improved technologies in terms of engine management systems, fuel injection systems, high pressures. There's lots going on the top end of these engines in order to make sure that you get that very efficient burning of the fuel. And again, these oxidation catalysts, so they all have a little go at it. So any unburnt fuel will get sort of oxidized by a diesel oxidation catalyst. And then carbon monoxide, not a very nice gas, but again it's an indication usually that the engine isn't running fuel efficient. So you're getting carbon monoxide generated rather than carbon dioxide. But again, improvements in the fuel systems, engine management systems, and also the addition of, yes, our favourite there, diesel oxidation catalysts, have helped reduce carbon monoxide output from these engines. So a lot of technology has got built into these engine types. And where we sit today with Euro 6 compliance, these things are all over the place. So obviously, engine oil technology and fuel quality, of course, I'll mention that as a caveat, are very important to ensuring all these devices operate effectively. So getting the engine oil quality correct is very important to make sure your after-treatment device efficiency is as good as it possibly can be to be compliant. And I think we all know there's electronic sensors everywhere these days. So as soon as that engine is not running within certain emission parameters, then the engine management system will kick in and tell you you need to get it sorted. And normally with a very expensive price tag. So make sure the correct quality of lubricant or performance level is being used in your engine to safeguard all this lovely expensive technology which is now packed into these engines and the exhaust gas devices. Okay, so essentially, and it's a bit small at the back, but don't worry, I shall again describe it to you in great detail. If we look back in the early 90s where we had Euro 1 compliance all the way through to Euro 6 compliance, you'll see, if you get closer to the screen, that the numbers are getting smaller all the time. So when you compare a Euro 1 compliant engine to a Euro 6 compliant engine, all these delightful after-treatment devices have done a cracking job of getting these levels very, very low. So at the moment where we stand, a Euro 6 compliant engine, certainly diesels for example, are pretty clean animals. You're never going to get completely clean exhaust gases from anything burning fossil fuel. But we are getting pretty close to the technologies that we are now employing in these new design engines. Okay, so we've got these lovely low emission engines, all these lovely after treatment devices, all this new generation of lubricants and fuels to help protect them and prolong their lives. That's great. But the tide's changing because diesel's always had a bit of a kind of hard press and it's kind of coming back round again now. So, you know, in the past we've seen that diesel, okay, CO2 output, it's higher than a petrol engine. Okay, you've got after-treatment devices bristling all over it. DOCs, DPFs, SCR, catalysts, you name it, they're everywhere on a diesel. So that's expensive. They need to be looked after. DPF regeneration has been a major issue with diesel particulate filters, purely because the kind of duty cycles that's expected of them to initiate a regeneration aren't always achieved. So a lot of cars have been sold that I know of which have been not fit for purpose, where it's been small, short distance commuter work and the DPF never properly regenerates. That of course becomes expensive, there's downtime, there's issues. And so the smaller petrol engine has started to take over from the diesel engine because it's better around town for short distances, commuting, stop-start work. So petrol has almost had a bit of a thumbs up. You know, it's had a bit of a resurgence lately because it doesn't have all these after-treatment devices on there. However, it's starting to become a bit of a problem fuel like diesel because everything has to get better and better all the time. So now petrol is getting the focus put upon it. So we are going to see potentially in the near future gasoline particulate filters. We've had our DPFs for many years. We're going to start to see gasoline particulate filters start to emerge. And we've also got a new phenomenon. I won't sing it like in the Muppet song, but low speed pre-ignition, that's the next big issue with petrol engines as we see them going forward. So I want to talk to you about these two issues today a little bit so you get a flavour for them. If you haven't experienced or not familiar with them, then hopefully you will be after today's seminar. Okay, so GDI, gasoline direct injection. It's quite prevalent now in the petrol engine market. They reckon around now this time there's about 40% of the cars on the road are employing gasoline direct injection systems. The actual legislation governing gasoline direct injection has been around since 2011, so 7 years old. However, the GDI population back in those days wasn't as high as it is now. So it's now becoming quite important. And a bit like diesel engines with particulate matter, PM, that's the solid stuff that you get in the exhaust gas of a diesel engine, we now have a particulate number which is attached to petrol engine emissions. So, because even in petrol engine emissions, there is solid debris. So that is now measurable. And a bit like that solid debris in diesel engine emissions, which can harbour carcinogenic compounds getting out into the atmosphere, petrol engines are no different when you start to put them under the microscope. So that's becoming a problem. And a bit like diesel engines, you put all these lovely after-treatment devices on there. The gases have got a bit more of a maze to get through to get out, so you get a back pressure on the engine. And because of that, that's a negative impact on combustion, which means you start to get reduced power and you get sort of a different kind of operational mode. So back pressure off a gasoline particulate filter can become an issue. Added cost. Okay, your average kind of DPF on a passenger car, anywhere around £800, £1,000 depending. So you're starting to increase the cost of the hardware on a petrol engine now as well. So you're adding extra goodies on there which have cost attached to them. And because of this, a lot of the car manufacturers or engine manufacturers are looking for alternative technologies to try and not go down the gasoline particulate filter route. So they're looking at swirl technology. This is where the fuel and the air mixture is mixed before ignition. So trying to improve the efficiency of that, for example. Cam timing. Variable cam timing now is not an issue. It's been around for a long time. So you can change the timing depending on the engine duty cycle to get your fuel efficiency where it needs to be. Fuel injection systems, well, again, as I say, they've improved over the years, but they're always getting tweaked, remapped, things changing, different porting, etc., etc. So a lot of the manufacturers, in order to negate the use of these GPFs is to move towards some of these internal strategies. But this will happen. Gasoline particulate filters are definitely again appearing in the marketplace. So you will need to be aware of them, and it will affect lubricant technology at some point in the near future. Okay, so just be aware of that. So we've had DPFs forever, and now we're on to a whole new kind of filtration system for petrol engines. Okay, and then the other phenomena, again I won't sing it, is the low-speed pre-ignition problem with petrol engines, which has been around for a while, but it's only really over the last, I would say, 12 months, 18 months, it's started to become an acute problem for certain engine types. And low-speed pre-ignition is essentially pre-ignition of the fuel-air mixture charge before top dead center. Boom, when you get the actual power stroke. If that pre-detonates, when the system isn't ready for it, you can get severe engine damage. There's some pictures there you can see, hopefully at the back, of what can happen to a piston when you get severe LSPI effects. So it can be pretty catastrophic. In the very, very subtlest of scenarios, it's the old knocking sound or pinking sound you may have got yesteryear, but in its worst case scenario, you're going to blow bits off your piston and damage the combustion chamber area. So it's going to become, and it is, a big problem in certain engine types. So everything is moving towards improving things like fuel quality, engine lubricant technology, and also engine design in order to reduce this. Because as we say, we've seen this trend now towards smaller petrol units in order to replace the diesel units which we've all been familiar with. So as the move towards these lower capacity petrol engines starts to go forward, where we are seeing turbocharging, supercharging combined to get these small 1 litre, 1.2 litre engines creating incredible horsepower, say compared to 10 years ago even, then we're going to see LSPI as becoming an issue with these types of engines. So from an oil technology perspective, and we've had inquiries on our stand already today about Dexos 1, so it's a General Motors specification, if anybody's familiar with Dexos 1. Dexos 1 includes LSPI performance, and General Motors issued a bulletin probably in the last 18 months or so, listing a variety of different engine types that they believe LSPI is a problem with, and they are starting to specify Dexos 1 as the preferred grade in order to try and alleviate this problem. So Dexos 1 will start to become more popular. We've lived with Dexos 2 for people who are in the sort of the Vauxhall, Opel kind of franchise dealerships or workshops. Dexos 2 has been around for a long time with petrol and diesel performance, but Dexos 1 is going to become much more popular. We're seeing a lot more demand for it. It's petrol specific, and one of its sequences within that specification is to address LSPI issues. We're also seeing Peugeot Citroën. They've been hot on, obviously now since they bought Vauxhall and the Opel brand. They've had LSPI issues as well for a while, so the PSA specifications that we've seen and enjoyed for a long time have been withdrawn, and there will be new PSA specifications coming through with LSPI being addressed for those particular units. And anybody who's familiar with the API classification system, American Petroleum Institute, API SN Plus is the kind of American version, if you like, of the European specifications, which deals with LSPI. So be aware of LSPI, it's here. There are problems with certain engine types, and the worst case scenario are the pictures that you can see on the screen. So incorrect oil quality will contribute and increase the risk of this happening. Okay, so what's next? Okay, so we've done NOx gases, hydrocarbons, particulate matter, carbon monoxide. We're squeezing them smaller and smaller, those numbers are getting smaller all the time. So where do we go next? And the next big step in reducing emissions and being good to the environment is carbon dioxide reduction. So what we're looking at now is to try and get all these engines out there more fuel efficient. So you can go further on a gallon of fuel. And if you can go further on a gallon of fuel because your engine is much more efficient, you produce less carbon dioxide. So CO2 reduction is the next big driver in terms of engine oil technology and where we're moving to. And to celebrate, we have a new engine oil specification. Oh yes. So anybody who's familiar with the ACEA classification system, which is a European classification system, our new classification ACEA C5 is with us. It's not very popular at the moment, but it's starting to creep into a lot of handbooks. So if you see ACEA C5, you're basically looking at new technology lubricant which is designed to reduce internal friction of the engines and improve your CO2 output, or reduce your CO2 output. So your fingerprint is getting smaller. Your carbon footprint fingerprint is the other end of the body. What am I talking about? So your carbon footprint is getting smaller and smaller. Okay, so there's a lot of jargonese and hieroglyphics and Egyptian stuff on that particular page, but the important thing, and I've highlighted, is at the top bit. Now, HTHS, high temperature, high shear, it's a kind of an unknown parameter, if you like, which is measured for engine lubricants, but it's becoming much more important, and I think it will get more into the lubricant language as we go forward, become more understood. And working with some of our technology partners, we are hoping to educate and explain what HTHS is. But essentially, just to give you a very basic overview, if you think of your journal and your bearing, okay, and your crankshaft, for example, journal and bearing is separated by an oil film. Okay, we need a nice oil film in there, and essentially when that engine is rotating, the crankshaft is spinning around, the journal sits on an oil film to separate itself from the bearing. So that's what it normally happens. But if you can imagine on the, let's call them older-fashioned type lubricants, the thicker lubricants, where the oil film separating is that big, a lower HTHS means it's down there, okay? So that oil film between journal and bearing is now getting smaller. And the smaller that oil film becomes, the less internal friction is generated. And therefore you become more fuel efficient and you produce less CO2. So oil film in these working mating surfaces is going to get smaller and allow carbon dioxide output to be reduced. Because the other thing you will notice with a lot of C5 products is that all the things like 0W20s, 0W30s, the thinner oils. So we're going into the kind of the thinner oil market, if you like, with things such as an ACS C5 category product. So it's starting to come through now. We've seen C5. We do have it available on certain products, but certainly going forward over the next 12 months, we'll be looking at where we can produce more C5 compliant products in order to satisfy the marketplace. So there we are. To celebrate, we have ACS C5. Not one of my favourites, but it's up there. It's up there. Okay, so in order to achieve all these lovely things, of course, just to give you a little bit of background, we've had to kind of improve the formulations, change the formulations. Formulations have evolved. The technology we use in developing formulations has evolved. So if you look at your average engine oil formulation, where we have the base oils, the runny bit, for want of a better description, and then we have the functional chemistry we would put in there that turns that base oil into an engine oil, into a gear oil, into a transmission oil. That chemistry has also evolved. So we've seen now all the base oil technology evolving, all the chemistry, the functional chemistry evolving. And one of the important things, or one of the biggest changes, really probably over the last, I would say even 5 years, we've seen a massive jump. Again, I won't bore you with all the little bits and bobs, but Group 1 mineral oil, okay, our favourite, okay, you can almost cook your chips in it, it's that good. Group 1 mineral oil has been around for a long, long time, okay? It's been the mainstay of lots of different formulations. It's becoming almost extinct now, because when we're looking at all this high-performance stuff we've been talking about, all these after-treatment devices, smaller units, higher outputs, it's just not cutting the mustard anymore. Group 1 is kind of on its way out, I'm afraid. It'll become a museum piece pretty soon. But we've seen this evolution now in base oil technology. And it looks pretty boring, because these products now, these Group 2s, 3s, 3 pluses, 4s, 5s, they're all new technologies which are very tailored, much purer, much cleaner, much more structured than the old Group 1. And by doing that, by having a much better base fluid to work from and start from, you're at a good place to start with a high performance fluid which is going to be tailored to looking after all these after treatment devices and the fuel efficiency requirements of these modern engines. And in the main, if you look at passenger car, for example, we're probably sitting around sort of Group 3 Plus is the main kind of base fluid we use now. So very highly refined, tailored products which give much better higher temperature performance, lower temperature performance. They also form less deposits as well, so everything has better operational efficiency for longer. So everything's evolved in terms of base fluid. And if you look at your average kind of formulation, this is one I prepared earlier, or didn't quite, because these are the parts of the jigsaw puzzle. If you take your average blended engine oil, for example, and you break it down and you look at it, and I did this accurately in the laboratory, I was in there for hours, I had to be told to go home at one point. But if you look at Group 3 base oil there, we have the additive system, we have the viscosity modifier, pour point, all have certain jobs to do in the formulation. But as you can see, and this is a 10W40 product, okay? Your average 10W40 these days is based on sophisticated Group 3 technology base oils. So everything's gone up again. But one of the other things that these kind of new technology base oils provide for you is better physical characteristics. Because one of the other things that changed as well, of course, is how thick the lubricants are. And I think, you know, most of us are waiting to your classic and vintage world. 20W50, the good old chunky mainstay of yesteryear, got thinner and thinner and thinner. And you know, we've seen this progression over the years from an SAE50 right down now to really thin products. I mean, we've got a 0W16 product. And there are thinner products being spoken about, but 0W16 for Hondas and Suzuki's, one or two other manufacturers. That's right down there. This is really thin stuff we're talking about. And although I'm not talking about gear oils particularly today, you know, gear oil technology has also got thinner and thinner and thinner. Where the old sort of gloopy 80W90s and yesteryear were great, good stuff cooking your chips in, it's got thinner and thinner and thinner now. And, you know, we are selling more and more 75W manual transmission oils. Everything's thinner. Automatic transmission fluids are getting thinner as well. So everything's getting thinner in order to make everything more fuel efficient, in order to reduce carbon dioxide output. And if we look at the multi-grade aspects of these engine oils, you can see, you know, 15W, 10Ws are around for a long time. 5W now is almost today's 20W50. 5W30 is your mainstay commodity product almost in terms of viscosity grade. Not performance level, but in terms of viscosity grade. But we are seeing more and more W's coming through all the time. And as I say, this new ACSC5 category will herald a new generation of W products across the range of products that we and other companies manufacture. So it's all getting thinner. So, to summarise, before I fall off the stage with excitement, we're getting thinner all the time, okay? We're moving to thinner viscosity oil grade. So 5W30, mainstay, yes, but 0W30s, 5W20s, 0W20s. This is where all the next generation of lubricants coming through will sit for passenger car and light commercial vehicle. These new base oil technologies that we're using, the Group 2s, 3s, 3 pluses, 4s even, they don't evaporate so readily out of the exhaust pipe. So a lot of these hot running engines now don't consume oil like they used to. The oil stays put in the engine for a lot longer, because if it was going out the exhaust pipe, it would be contributing to emissions, so that can't be allowed. These new technology base oils as well allow better cold start performance, because when you start that engine up, you're still looking at fuel economy for that engine. And if the oil's thick and gloopy in the sump of the engine when you try and start it up, you are wasting fuel, you are contributing to CO2 emissions. So these new technology engine oils going down to 5Ws, 0Ws are improving cold start performance and therefore reducing CO2. New technology engine oils are also better at not forming deposits when they get hot, okay? They are quite clean in the way they operate. Because if you want the engine to operate efficiently, you want it to operate cleanly all the time. Because if it's operated efficiently, you're reducing CO2, you're reducing emissions. And then finally, mid and low SAPs. I haven't explained that today, but for after-treatment device compatibility, these new SAPs technology products have to be used to protect after-treatment devices. Because if they're working correctly and efficiently, you're reducing your CO2 levels and you're reducing your emissions. So that basically is my final slide. Well, that will hopefully give you a flavour for where we're going. So we're getting thinner, we're trying to reduce CO2, and we're looking at, say, W's, thinner oil grades all the time. And beware of LSPI and beware of gasoline particulate filters, because that's out here now, and that's starting to impact on this particular marketplace. So, thank you very much. Any questions? There's a rolling mic, I see. Rolling at the back there. Anybody got any questions? If you haven't, or you have, but you don't want to voice them here, please come and see us on the Morris Lubricants stand, which is
P105.
P105, thank you very much. Oh, we have a question, excellent.
Adrian, we can't let you escape without a question.
Oh, I recognise you immediately.
So I thought I'll do one.
Thank you.
So hybrid technology then, are you seeing anything in the field in terms of extra water build-up in hybrid engines that's affecting the performance of the oil?
I think one of the biggest problems is water build-up, because a hybrid engine is designed to kick in and out, whether it's petrol or diesel, you never really get to that operating temperature that you would if it was on constant operation. So it is a problem. How it's going to be fixed, I'm not sure. It's like a lot of these new technologies, it's early days. And of course, one of the other problems we're seeing potentially is activation temperature of a lot of the additive systems, because they rely on a particular activation temperature to work correctly. If you're only sort of kicking in every now and again as sort of a gen set to back up the battery, it may be that new technology will have to be evolved as well to look after that intermittent use. So we see these particular challenges, and hopefully working with our technology providers, we can overcome them basically. Okay. Anybody else? Oh, steady. Thank you very much. And just finally, this is nothing to do with it. Well, it is. We're very much involved with this, but VLS, verification of lubricant standards, specifications. I've been asked to mention that today. They're very close to us over there. I can't remember. Was it M109 or something? Yes. This is basically policing the aftermarket in terms of the lubricant industry. So Morris Lubricants and various other reputable suppliers into the marketplace are basically trying to protect the interests of the end customer by ensuring fair play when it comes to marketing lubricant technology. So if you need any more information on that and what VLS are doing, please visit their stand, and I think the Director General is there today, so you'll be treated for Rochers and all sorts of things. So please visit the VLS stand to learn more. But thank you for listening, appreciate it, thank you very much. Thank you.